Hey everyone, this is Bobby at Copal TV Repair, and this is a functionality proof and a quick how-to test video for TCL power supply board 08. Somebody is sensitive towards seeing my feet on those videos. 08-P602W0L-PW250AA. A lot of people count those as these 0L. I can see a lot of websites are counting that as OL, but it's 0. So it's always wise to search for both of those whenever you want. So the board came with the main fuse not blown, but that will be a first thing to check to know whether that board is bad or not. Will be to check the main fuse, because there will be enough failures where it will be blown. So the one that came, the main fuse wasn't blown, the TV wasn't working. However, the small fuse here, this one, originally it is red and more rectangular instead of a cylinder. That was open, and the way to find that out is to just test it on the back, where you can find it and test it. And if you find it bad, that's where it is. If you find it bad, don't replace it. I'm using the moment to show the customers this is their board, and it fails because those two have failed, or those two, one of, I don't remember which pair, but it will be easier to find. And we found other damage there in the standby circuit, etc., etc. Everything is taken care of. This board is, I'm going to be showing that it does work. It is slightly different than the smaller cousin that they have for the same model, just smaller size. 635 is the model, but for the 55-inch version they have that board. And we also repair and we also sell those, but they're slightly different in that on the bigger boards there are 3 different levels of activation. So there are 3 outputs on this board. One is the standby. Here it's provided by this guy, and it only outputs 12 or 24, I don't remember. I think it's 24 volts here on the control. This is the connector that goes to the main board. Then they have 12 volts output that goes to this connector, and it's produced by that transformer. And then they have the output for the LED driver, which is produced by those 2, rectified here and sent out. The standby is always there, and it's, I believe, 24. And the other 2 are activated through the switches that are on the connector. As you can see, they have backlight on, power on, which is the major, and 3D enable. 3D enable, which on the other board is only passed between the main board and the LED driver. In this one, actually control the release of 12 volts to this connector. So to activate the power board first, in addition to having the standby should appear there under 24 volts. So as soon as you plug the board in, it should produce 24 volts on this connector here at the bottom where it says 24, 24. So the last 2 pins should be 24 volts to ground. To wake up the power board, turn the power factor correction and also get the 24 volts for the LED output. What you need to do is you need to send 5 volts to power on, P on. And to wake up the 12 volts for the 3D, whatever that means in that TV model, I don't really know. But you can see the 12 volts being produced on that board, even only after you activate it with the power on. However, you are not going to see them here because this switch, which is a pair of MOSFETs working in parallel, aren't enabled and they're not letting it out. You can see it here being rectified and present, but it's not going out. And in order for it to go out, what you need to do is you want to activate the 3D enable. That's what took us a while for the customer. We sent them a note earlier today showing that saying that we basically fixed the problem with the board, but that one voltage wasn't going on even though it was produced on the board. It was the one that is controlled by the 3D enable activation. So there are 3 voltages that are going out of that board right now. 24 volts on the standby, 12 volts on the 3D enable that goes probably to the T-cone, because that's where the 3D enabling will work, and this goes to LED driver. Those are, I believe, 12 volts. Whatever it was, it said on the back how much they are. We have a little jig here that does that for us because we were afraid to send 24 volts back. And also we have a little resistor because on the previous board, I don't know if it's true for this one, but the previous board did require a load. Now that resistor should be a little bit more powerful than what we have, and it tends to get hot pretty quickly. But what I'm going to do is I'm going to try as fast as I can to first power the board. You will hear the relay click. There you go, it went. Our indicator here shows that this is working. First, well, the fact that the LED is there means that it is getting power on. So this is the 12 volts on this connector because the 3D is enabled, and this is the 24 volts. All of those you can see at the back, they have a lot of, half of the connector is ground, half of the connector, there you go. This is all the board with one caveat. As always, I should have started probably with that for many people. This is 99.9% reliable testing for any power supply board. To test it fully and properly, it has to be checked under load. Now, those don't specify. Many of the Samsung boards, for example, do have somewhere printed on the board what output they provide, what voltage and what current, and one can measure them there with that. The proper testing does require load to be put always and always, but because it is extremely uncommon, at least in my experience in 20 years, I have seen maybe, I don't know, 10 or so boards altogether out of easily thousands that are only sensitive to and only start playing tricks when they're loaded. It is not cost efficient. We don't do it. We don't do it unless we do know that a particular model tends to develop. I can think of a particular Samsung model that does develop indeed an issue. I do have a connector somewhere here that's for BN44-00183, which only under load tends to fail. And I do have a connector somewhere that emulates the load on 183 exactly for that purpose. But most of the time we will only test under load when we have feedback signal from the customer, reason to do that. Otherwise, it's simply not cost effective to run every single board throughout that. So that's why I'm not doing it. And that's why I'm not gonna continue be doing it for other tests. It's not that I don't know, it's not cost efficient because it happens so rarely. That's all. Hopefully you learned something useful. I'm not showing you how and what to repair in the individual circuits. I mean, we have to make some money after all by providing some service in addition to making free videos, right? So if you want your board repaired, or we will try to see whether we can modify another board into this one so we can sell them, check at our website. Best of luck with your repairs, and talk to you soon.